All right, we are back at AP Review. This is 2005 Form B, AB, BC, free response 2. All right, so this is the classic rate in, rate out problem. So, a water tank at Camp Newton holds 1,200 gallons of water at time t equals 0. During the time interval from 0 to 18 hours, water is pumped into the tank at a rate that is W of t, rate in W of t, which I'm going to store in my calculator as Y1. And I'm not going to read it, but you can read it, it's fine. And during the same time interval, there is water being removed from the tank at R of t, which is the rate out, and I'm going to put that as Y2 in my calculator. Cool. So, a classic rate in, rate out problem. So, in your calculator, and it's good on your actual AP paper for your own benefit to note which one you called Y1 and Y2 in case it matters, even though calculator notation doesn't help you. So, there's my calculator. Right, when I said if you want to set a window that works, I set a window where my x's went from -2 to 20 because I like to see, or -2 to like 23, because I like to see on either side of the interval, and I used my y's from like -10 to 300 because I noticed that with an amplitude that was 275, 300 would be safe. So, or that was my assumption, was that 300 would be sort of safe-ish, and it worked. So if you graph your calculator with that window, you get something that looks like that. All right, cool. Is the amount of water in the tank increasing at time t equals 15? Why or why not? Okay, so part A, remember that part of this is getting the logic behind it, right? So the trick is that if the total amount, right? So in fact, if you want, you could call, like, you could say, oh, A of t is what I'm going to call the amount, right? You could be like, that's the amount in the tank, right? And this is your own personal notation, right? Personal notation. What I want you to recognize is that the rate of change of the water in the tank, right? So A prime of t would be the rate in, W of t, minus the rate out, which would be R of t. So if you want to know if the amount is increasing or decreasing at 15, what you would want to do is find W of 15 minus R of 15. And there are a couple different ways to do that. So one easy way to do that is that you could go to table set, right? So you go to table set, which is second, and then window, and you could say, hey, I really want to know what happens at 15. And then if you go to your table, you'll see that you get a y1 value, and if you scroll over, you get the whole value, right? So you're going to get that this is a 131.782, yada, 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 right? Minus, and if you scroll over to the other one, you're going to get a 252.872, blah, 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 right? So what happens, now another way to do this if you want is you could actually put this in as y1 minus y2, like in your y3, right? But when you subtract these, you're going to get this as negative 121.09, which is less than 0, right? So since a prime of 15 is negative, the amount is decreasing. The amount is decreasing. And now there's another logical way to say it. You could say it in words. You could say the rate out is bigger than the rate in. If you're losing something faster than you're gaining it, then you have a net loss. Cool. So that's worth 1 point. Part B. To the nearest whole number, and that's important because usually we don't do whole numbers, how many gallons of water are in the tank at time t equals 0? So, interesting side note, is that if you had wanted to put W of t minus R of t in as one of your y's, that would also be fine. But so here's the trick for B, right? I know how much started in the tank. 1,200 started in the tank, right? And I know that the amount from, they said 0 to 18, the amount from 0 to 18, since this is the rate, right, the amount should be essentially, you'd integrate the rate. So I should get, this is the integral from 0 to 18 of W of t minus R of t with respect to t, right? So this is the setup I want, and that's going to get me probably 2 of these points, right? So again, what you're doing here is you're taking the starting amount, and this is the amount of change, right? This is the net change, right? This is the net change. This is how much the amount of water in the tank changed. And if it helps you to think about it as A prime of t, right? But if you're given a rate at which something changes, to find the total quantity of change, you want to find the integral. So when I put this in my calculator, I'm going to do function integrate, which is math 9, y1 minus y2, because based on the notation I used, that's y1 and y2, with respect to x from 0 to 18. And I need to make sure that I add that to a 1200, right? when I type that in my calculator, I'm going to end up getting that this is a 1309.788. But they said in this one particular instance, round to the nearest whole number, so that's a 1310, right? So there are 1310 gallons in the tank at the end of time, 18 hours. Cool. All right, part C. At what time from 0 to 18 is the amount of the water in the tank at the absolute minimum? Show the work that leads to your answer. Okay, so I'm going to keep this a prime of t equals, all right, equals w minus r. So again, it really helps to have this for your own personal notation, right? So they want to know, so in part C, they want to know when is a of t have an absolute minimum, right? And again, that's my notation, not their notation, right? But the trick is that if I want an absolute minimum for a of t, I need to consider a prime of t, right? I need to consider the critical points. And that logic is still there even if you're using a notation that you made yourself. So critical points happen when a prime of t is 0, when a prime of t does not exist, but that's not an issue because they're both sine functions and sines exist, right? Sines exist. Sines don't have any weird, they don't have any weird asymptotes, they don't have any spots where they don't exist, or at the endpoints, right? So see, the other kind of critical values are the endpoints, which are 0 and 18 in this instance. So I need to consider these 2 points, because they did give me the included window from 0 to 18, and I need to consider points where this quantity, w of t minus r of t equals 0. Well, that's just saying, where does w of t equal r of t? Right? Which I can find by doing y1 equals y2 and second calc intersect. So the honest answer is you don't need a sign chart, you don't need all this other crazy stuff. What you need to do is consider these 2 points and consider however many of these points you find, and then just find the physical value. That's the easiest way to do this, right? Find the value of a at those windows, right? So when I go ahead and second calc intersect, I'm going to get that there are 2 answers. I'm going to get that it happens when t equals 6.495 and when t equals 12.975, right? If I consider these, right, and it's actually like not 9.5 if you want, you can list all of the points. You really should list more of the points, so I think you get this much when you type it in your calculator. So 4.8, I think. All right, cool. So these are the points I need to consider, right? So I just need to find the a value, right? And we already know how to find a, right? It was 1,200 plus the integral from 0 to whatever that x coordinate is of my w of t minus my r of t dt, right? We already did this. You can actually second enter and type in exactly what you did for the last part of the problem, except instead of doing 0 to 18, you can do 0 to whatever these quantities are. So if I were you, when you find this, so just to be clear, when you find this value, the way you store that, so I'm going to store this guy as a, and I'm going to store this guy as b, so that when I type in my calculator, I type the whole value. So if I were to find second calc intersect, if I do second calc and I pick intersect, right, I'm going to scroll, oh, I'm way over there. I'm going to scroll over to the first point of intersection, which is that 6 point whatever, right? So scroll over to the first point of intersection. I'm almost there. Okay. I hit enter, enter, enter. Now it's going to give me a value. It's that, in theory, there we go. It's going to give me a value. Now if I quit out of this and hit the X, it's going to be that value. So I'm going to store that as alpha A. So I didn't have to type it. I didn't have to write all that down. I stored that as A. Then I'm going to go back to my graph, and I'm going to second calc intersect again. I'm going to scroll to the other one. It's not a short distance. Scroll to the other one. Okay, there we go. Okay, enter, enter, enter. It's going to give me a value. It's going to be that other one, the 12.9 stuff. There you go. Second quit, right? And then X, enter. There's that value. I'm going to store that as alpha B. So now, here's what I'm going to do. I'm going to consider at those different t values, at 0, at the one I called A, at the one I called B, and at 18, and I'm just going to find the different A values, and I want the one that is physically lowest. And I know that those are the only places I could have my lowest value, so if I find those, I'm good. So if you look, if you go second enter a few times, oh, I didn't type it. I stole it from the AP. I was lazy. Let me fix it. So if I do 1,200, right, plus math 9, so if I do 1,200 plus math 9, I go to vars, I go to function, y1 minus vars function y2, comma, with respect to x. So the only difference is going to be what number I'm putting in here, right? So I already know what the value is at 0. Like, you don't have to do any work there. You're just, that's a 1,200, right? for this one, I'm just going to put in A. So what I'm going to do is I'm only going to do this once. I'm going to do 0 alpha A, right? So that's my first value. It's my first value. It's still thinking. It'll get there eventually. And then once I've done this once, I'm just going to second enter and find the other values. I already also know the value at 18 because we did that one, right? I got a 1310. Cool. So I get that this is a 525.242. Great. Then I hit second enter, and I just changed the alpha B to an alpha A, and I hit enter. And I'm going to get that this value is a 1690 something. I stole that from the AP's answer guide, so I'll just wait for it to finish calculating. Oh, math. There we go, 1697.441. Now, they asked me to find the absolute minimum. So the absolute minimum happens here, right? So my answer is at T is approximately 6.495 or 4, depending if you round or truncate. And I should put units. The units were measured in hours, right? So the trick here is that this is worth a lot of points, but it was primarily worth, so you got 1 point for getting these critical points on the interior. You got 1 point for giving the answer that it was the least at this value, right? And you got a point for the analysis, meaning that you actually showed some kind of work to show it's an absolute min. You could have done this in a different way if you used sign charts of some kind. I would argue the easiest option is to say these are the only critical points, and of the only 4 critical points, the one with the lowest value has to be this one. So, cool. And they don't ask what is the amount of water. They ask when is it the minimum, so you don't actually have you don't have to give this value with gallons as an answer. All right, last bit. For T values greater than 18, no water is pumped into the tank, but water continues to be removed at R of T. Let K be the time at which the tank becomes empty, right? But do not solve an equation involving an integral expression that can be used to find K. Okay, so here's the thing that's happening, right? So we know how much water is in the tank at the end of the 18 hours, right? So for part C, we know that there are 1310 gallons left in the tank, right? This should be equal to the integral from 18 to whatever time k it is of that rate that it's being removed. And that's really all I want. So this is the amount left, right? And this would be the amount removed from t equals 18 to t equals that mystery time k that we don't know. And that's all they want. Sorry, cut off the k, didn't mean to. That is all they want. Cool. So you get essentially 1 point for the equation and 1 point for knowing that the limits are from 18 to k.